For this table, let us first identify whether it shows direct variation. Observe the values of n, 1, 2, 3, 4, 5, and 6. It is increasing. The values of c, 12, 24, 36, 48, 60, and 72. It is also increasing. Then the situation represents a direct variation. Now let us write the mathematical statement that relates the quantities n and c. For this, we can say that c varies directly with n. And then we are going to solve for the constant of variation. As we all know, the constant of variation for a given direct variation is k equals y over x. And in our problem, our y is c, while our x is our n. So, let's take n is equal to 2 on the table and c is equal to 24. So, let's substitute it here. C over n. That would be k is equal to 24 over 2. And 24 divided by 2 is equal to 12. Therefore, we can say from this solution that our constant of variation is 12. Let's try 36 divided by 3. It's also 12. 48 divided by 4 is also 12. This 12 is the constant of variation of the given table of values. Now, let's have the equation. Since we already have the constant of variation, we will change the value of our constant from our initial mathematical statement. So, this time, we will have c is equal to 12n. This is the equation of the given table of values. Here is another example with some missing values for x and y. The first thing that we need to do is to write the statement into an equation. Y varies directly as x. So we can say that y is equal to kx. And then we find the value of our constant by applying what we've learned. In finding the value of k, we simply divide y with x. And let us use a pair with values of x and y. In this case, we have x is equal to 6 and y is equal to 2. And then we substitute this in our equation. K is equal to 2 over 6. Let's change this into its lowest term. 1 over 6 is equal to, 2 over 6 is equal to 1/3. This is now the value of our k. So what will be our new, or what will be our equation? That would be y is equal to 1/3 x. This will be the equation for our table of values. Next, now we can answer the question, what is y if x is 18? So let's have that given. Y is unknown. for x is 18. How are we going to solve for this? We apply and use this equation. Y is unknown is equal to 1/3, which is your k, and the value of x, which is 18. Now, y is equal to 1/3 of 18. We can use cancellation. 18 divided by 3 is 6. 6 times 1 is 6. Now, for this, we have the value of y equals 6 when x is 18. Then let's proceed to another question that asks for the value of x. This time, the missing is x. What is x if y is 9? Then again, we will use the same formula to find the value of x. We have y is equal to 1/3 x, right? So we have the value of y, which is 9, is equal to 1/3 the value of x, which is still missing. Okay, then, how are we going to remove 1/3? What are we going to multiply to both sides of the equation to make the value variable x on the the right hand side of the equation? We multiply both sides by 3, so that 1/3 times 3 is equal to 3/3, or 1. 1 times x is equal to x. And then on the left hand side, we have 3 times 9 is 27. This is now the answer to the next question that completes the table of values that we have. Okay, do you have any question on that? Okay, thank you. When dealing with graphs, first is we need to get the mathematical statement for the graph. As we see from the graph, it is increasing. So we have y in the y-axis is equal to kx, as it represents a direct variation. Then we take some values of x and y. For example, we take y is equal to 6. If x is equal to, what's its pair? 4. Okay? And then we also have when x or y is 12, we have x is equal to 8. So let's just take these two pair of values from the given point in this graph. Then we solve for the value of k. To solve for k, our formula again is y over x. Then we substitute for the first given to find k equals 6 divided by 4. Lowest term of it is 3/2, or 3/2. Okay, that's the k. Let's take the k for the next set if they are the same. That would be k is equal to 12/8. GCF is 4. 12 divided by 4 is equal to 3, and 8 divided by 4 is equal to 2. Therefore, they have same values. Then we can say that our constant of variation is 3/2. Now, let's substitute this 3/2 with our equation. That will make it y is equal to 3/2 x as our equation of that given graph. Okay? Same. We are going to find the constant of variation and the equation that describes the relation. Let's take um, N produced by a machine, and the T time in hours the machine is working. So we have the equation of this. We have N is equal to K T. N is in the y-axis and T is in the x-axis. Let's take points to be able to find the value of our K. So in the y-axis, we have y is 1,800 when x is equal to 2. Or let's take the other one, y is equal to 9,000 when x is equal to 10. And then find the value of k. K is 1,800 divided by 2. The answer is 900. Let's check if that's the same with the other point from the graph. 9,000 divided by 10 is also 900. Therefore, the constant of variation for this problem or for the given graph is 900. Then let's change the equation, and now is equal to 900 t for the equation of the given graph.